Good morning, everybody. Thank you very much for the invitation to be here. I've been learning a lot, and just to manage expectations, you're not going to learn anything about space-based solar power from me. But hopefully hearing a few stories is a good way to start the day. So when I was at school, I took part in a program called Future Problem Solving, which is nowadays called Global Issues Problem Solving. It was actually a really good extracurricular activity for developing critical thinking skills, creativity, and teamwork. So what happened is early in the year, you get given a list of topics for the 4 or 5 sessions that you'll have throughout that year, and you do some general research on those topics. Then when the time came, you're sat in a room with 3 teammates. You get given a future scene, which is a scenario based on that topic set sort of 20 to 30 years in the future. Then you have to identify 16 problems from the scenario. You have to identify an underlying problem which encompasses all the major challenges, 16 solutions to that underlying problem, a set of criteria for ranking the solutions, and then you have to rank the solutions in a grid using the criteria you've selected and write up your best solution into an action plan, and that's all in 2 hours. So these are the topics that I studied during my time in FPS, and remember that this was sort of 25 years ago, so topics like the internet were very much in the future at the time. In fact, my team won the international championships in 2002 with the topic virtual corporations. So it was a while ago. But the topics that resonated the most with me were really those that related in some way to the environment, and you can see a few examples highlighted here. So world population, water, habitats, alternative energy, and environmental law. So perhaps it's not surprising then that I went on to study engineering, and I did a PhD in hydrogen storage for fuel cell vehicles using nanomaterials, and you may have noticed that nanotechnology was another one of those topics. And then afterwards, I changed tack a little bit, and I did a postdoc and some subsequent research on a material called graphene, you may have heard of, which has a huge range of potential applications, including for space, and in particular I worked on thermal management systems for satellites. But whenever I could, I brought it back to energy applications like batteries and supercapacitors. But in the midst of my graphene research, I did something different again. I spent a year doing climate change research in Antarctica. So in 2019, among a whole bunch of other tasks, I was launching weather balloons every day at fixed times from one of the most isolated bases in Antarctica called Concordia Station. This station is also known as White Mars because it's the closest thing we have on Earth to what it might be like on the red planet. So on this glacial plateau at close to 4 kilometers altitude, 600 kilometers from the nearest other humans, in the permanent darkness for 100 days, reaching a wind chill of minus 104 degrees Celsius, and lit only by the light of the galaxy itself. The measurements we were taking there became the baseline of the local weather and atmospheric pollution models, which then became the baseline for aggregate climate data globally. So I felt extremely privileged to be in such a position, the custodian of experiments that people had put their life's work into designing, but they couldn't be there themselves in Antarctica to look after them. Now, Concordia Station exists where it does, at a place called Dome Sea, thanks to a project called EPICA, European Project for Ice Coring in Antarctica, the results of which you will be very familiar with. So researchers drilled an ice core of about more than 3 kilometers long. They cut it into slices and analyzed the air bubbles that were in each of those slices. So they could correlate the depth in the ice core with the period in history, and that's how we get this graphic of the concentration of carbon dioxide and methane in the atmosphere going back 800,000 years. You will have definitely seen this graph before, showing that the amounts over the last 100 years or so have really ramped up. Being on that location means that you are really in a privileged position to understand the status of the planet and also to share that with the world. So we held a lot of video conferences, mainly with school students, but also with public events, where we shared our research and our impressions, our sort of mini version of the overview effect that a lot of astronauts experience when they go to space. And then, well, this happened. So my time in Antarctica had taught me a lot about myself, both about my strengths and also about my limitations. I found that I really loved being the custodian of other people's experiments. And I discovered that I did have the capacity to pick up things from a completely different field and implement them quickly and well. I enjoyed working in an extreme environment with a small international crew, completely isolated for months of the year. And so this gave me the confidence to apply to the European Space Agency when they opened up applications for astronauts for the first time in 13 years. And my time there is probably what helped distinguish me among the almost 23,000 applicants to somehow become a member of the European Space Agency Astronaut Reserve. I felt honoured and really humbled to have been selected. But now how do I reconcile this with my history of alternative energy and climate change research? So let's turn back a moment to future problem solving. What is the scenario that we are facing at the moment? We saw the epicographic with the carbon dioxide and methane levels going back 800,000 years. This is another famous one, with the global temperature difference from the 1971 to 2000 average between 1850 and 2022. That's the span of this graph. The darkest blue is about 0.6 degrees colder than the average, and the darkest red is about 0.6 degrees hotter than the average. The trend is clear. The past 20 years have been consistently hotter than the average of the previous 30, not to mention the 120 years before that. Extreme weather events are on the increase, droughts are more common, sea levels are rising, species are disappearing, food supplies and human health are at risk, and many people are ending up in poverty or displaced from their homes. At the same time, we are burning more fossil fuels, a finite and polluting resource, than ever before. So it's not hard to find 16 problems in this scenario. In fact, the biggest challenge is limiting it to 16. And if we drill down to the space sector, we have our own share of the responsibility, most notably through space launches, though a lot of work is, of course, being done into sustainable rocket propellants. So since being selected in the class of 2022, one of the questions I'm asked the most by adults and children alike is whether my work and the space sector in general is good or bad for the environment. Because the most visible, the most memorable, most visually striking images in people's minds when they think of the space sector are often of plumes of rocket exhaust and orbital debris. Notwithstanding that we know that the space sector supports the work of climate science, I'll go into that in a minute, and all the effort that we make to place sustainability as a watchword of all our programs, the general impression is that space is part of the problem, not part of the solution to climate change. And this question that I am asked so frequently, are we good or are we bad? It's asked out of a hope, a desire, a vague but optimistic understanding that our science-centric and future-focused industry can and should be at the forefront of research, monitoring, and mitigation efforts. And we are. But clearly we're not clear enough in expressing it, nor loud enough in saying it, nor strident enough in emphasizing that space for a green future and supporting the Sustainable Development Goals is a guiding principle of our sector. So this was a survey performed by YouGov, asking whether humanity should focus more on space exploration or on tackling the climate crisis. I think probably all of us would actually answer. If we were asked this question, we would probably answer the same thing. The classic fix your own problems before you take them elsewhere. But if you think about it, this is a false choice because space exploration has demonstrably accelerated the resolution of many of the problems here on Earth. So it's a bit of an unfair question to ask. But it is clear that societal concern over climate change is extremely high. In a 2023 survey by the UK Office for National Statistics, around 2/3 of adults in Great Britain said that in the past 12 months they had been worried about the impact of climate change. And this climbs even further in the younger generation. So in 2021, Votes for Schools and UNICEF UK found that out of around 46,000 children surveyed, 95% were concerned about climate change. 89% felt that not enough was being done, and 81% of young people felt that they were not being listened to. Of course, the space sector is extremely important. It's an extremely important part of the fight against climate change. More than 50% of essential climate variables can only be measured from space. These include the atmospheric domain, wind, precipitation, clouds, Earth radiation budget, greenhouse gases, ozone, the oceanic domain, sea surface temperature, salinity, sea level, sea ice, and the terrestrial domain, lakes, snow and ice, albedo, leaf area, soil moisture, fire disturbance. And of course, this data goes into making important decisions around climate policy, around urban and agricultural planning, and disaster relief, among many others. But as hugely important and significant as this is, it is essentially a passive approach. Monitoring does not automatically equate to mitigating climate change. So that's the scenario we face, or a taste of it. So under the future problem-solving model, we've identified our challenges, and now it's time to come up with an underlying problem. And let's frame it from the point of view of the space sector, because, well, that's who we are, and that's what we have the potential to influence. So an underlying problem is made up of a condition statement, which is a short phrase describing the situation. I haven't included it here because we've just been talking about it. A stem, which is the how might we, or in what ways might we. A key verb phrase to describe what you want to do. A purpose to describe why you want to do it. You can also contextualize it further with words describing the time, place, and topic. So I've had a stab at it, and this is what I've come up with, one of many possibilities. How might we move from a passive to an active response to climate change so that the space industry becomes a global leader in creating a greener future? So this attempts to address both the difficulties related to climate change directly and public support for the space sector as a consequence. So I'm not going to go through and identify 16 possible solutions. We would be here a while, but it does seem to me that space-based solar power would be a really promising one, a really promising solution to this particular underlying problem. A chance for the space sector to provide an active response to climate change by directly providing large amounts of clean energy and reducing our reliance on fossil fuels. So it has its own challenges, many of which we've spoken about yesterday and will be spoken about in the next 2 days. I'm not going to go into either the benefits or the challenges because you're the experts and you know far better than me. But I want you to know that I am excited about the possibilities. So as an enthusiast, but not an expert, there are a few things that I can do to try to help. So just as my Winter Over crew had a platform to spread the word about climate change research in Antarctica, as a reserve astronaut, in one way or other, I'm an ambassador for space, and I will try to be your advocate. Tell me your stories and I will try to spread them. So I'm also a volunteer Wikipedian, and I thought it was important to highlight some of the work that is going on in this sector on that platform. So I wrote the article on Wikipedia on the European Space Agency Solaris program. Please go ahead and make your own contributions, just remembering that everything has to have its secondary sources, and it can't just be a promotion of yourself or your company, because that wouldn't survive community review by the Wikipedia community. But even with that restriction, there's a lot that can be said and a lot that the public can learn from you. So to conclude, as a representative of the European Space Agency astronaut class and of our industry, when I'm asked whether we are part of the problem or part of the solution to anthropogenic climate change, I want to be guilty of nothing more than being an ambassador for sustainability. What more can we do? What more should we do to show, not merely say, that our sector is doing space sustainably for a sustainable Earth? I'm truly excited about the potential for space-based solar power to solve our underlying problems.